if this condition is valid for rigidity of any object called rigid body, if this is a rigid body, under the definition of the rigid body, that which cannot be deformed ideally. Deformation means stretching, compression and twisting. The three quantities or three effects are absent. How high or how strong the force may be, how strong the torque may be, you cannot deform it, you cannot compress, you cannot elongate, you cannot twist it significantly. That's the rigid body. Mathematically you can say that when you take 2 points, the body cannot be twisted, it cannot be elongated, it cannot be compressed. Then we can say that the distance of separation between any 2 points of the rigid body remains constant for all the times. Then the distance of separation of any 2 points inside or of the rigid body the distance of separation of any 2 points inside or of the rigid body remains same for any condition, for all conditions or always. If this is the case, this is the condition for the rigid body. If you take all these effects into account, the elongation is 0, the compression is 0 and the twisting is 0, then we can say that the relative separation between any 2 points of the rigid body must be a constant quantity. Then we can say that the derivative of this quantity, if this quantity does not change, its derivative must be equal to 0. But what is this? Signify physically. This signifies physically that the relative motion or relative velocity between any 2 points of the rigid body along the line of separation is 0. This is the relative velocity between the points 1 and 2 along the line of separation that is 1, 2 is equal to 0. Along this line, both the points must move with same velocity. So v1x must be equal to v2x. Or you can just write v12x, the x component of the velocity between these 2 particles, or the relative velocity of these 2 particles or 2 points along the line of separation is 0. There is no relative velocity exists between these points along the line of that separation. or you can write v1x will be equal to v2x. This is the condition. Let us take an example. This is the rigid body. This point velocity is given 1 meter per second. This is point A, this is point B. Suppose this is 30 degree. This point, say, move in this direction with velocity 2 meter per second. Calculate this angle theta. For rigidity or rigid body, let it be x direction. Velocity of this point A along the x direction and the velocity of the point B along x direction must be equated. Vax will be equal to Vbx. Vx is how much? 1 cos 30 degree. Vbx is how much? 2 cos theta. Now cos theta is equal to cos 30 degree by 2. But cos 30 equal to sin 60, that's root 3 by 2 by 2. So root 3 by 4. So theta is equal to cos inverse root 3 by 4. Answer. So if the body is rigid, find theta. If the body is rigid, we can calculate theta by using the condition of rigid body, which states that the relative velocity between any two points of the rigid body along the line of separation is 0, or these 2 points move with same velocity, same speed, same direction along the line of separation. So the definition of rigid body is over. By using this concept, we can proceed to define the angular quantities of the rigid body. There we will discuss the angular displacement, the angular position, the angular displacement, the angular velocity, the angular accelerations, all these angular quantities in this section.